Hello, chemistry. Mr. McKee here again. This is the second installment of our mole conversion problems. So if you take a look at the top of the smartboard here, this is what I call our mole conversion roadmap. And by the time we're all done, we're going to be able to convert between any of these three things. Okay, we can go from moles to mass, for example. That's what we're going to learn about today. We can go from moles to number of atoms. That's what we learned about yesterday. Or I'll show you in red here. We can go in two steps from number of atoms to mass or vice versa. So really we can move anywhere along this roadmap. But as I said, today we're going to be focusing on this portion over here. So single step conversions from either mass to moles or moles to mass. So let's get into it down here. The first thing to note is when you look at the periodic table, you are going to see a decimal number here at the bottom of the periodic table. And that is our atomic or molar mass. So that is the mass in grams of 1 mole of a particular atom. All right? So that gives us another conversion factor if we scroll down here. So for example, with titanium, 1 mole has a mass of 47.88 grams. So we can use that as a conversion factor. We would then write it like this: 1 mole over 47.88 grams, or if we need to flip that fraction over, we could write it as 47.88 grams over 1 mole. And we're going to use one of those fractions as a conversion factor to solve one of our conversion problems. So let's get right into our first example here. How many grams are in 3.5 moles of nitrogen? Okay, so we're going from 3.5 moles of nitrogen to grams. That's going to be my starting and ending units. So I put 3.5 moles into this portion of the box. I put grams over here. That lays out my game plan. And I check the periodic table, and I see that nitrogen has a molar mass of 14.007 grams. And again, that is the mass in grams of 1 mole of nitrogen atoms. So as I always do, I'm going to put my starting number and unit down into this box, and then I'm going to multiply by my conversion factor, and I'm going to arrange it so that I can cancel out the unit that I'm trying to cancel out, which in this case is moles. So I put moles on the bottom, and that allows me to cancel it out. And that gives me units of grams for my answer, which is what I'm trying to do. So when I multiply 3.5 by 14.007, what I get in the calculator, bear with me one moment, is 49.0245. So that is my calculator answer. And if you put that as your answer, you would get most of the points, but not all of them, because you also need to round things correctly. So to round this, I look over here at my starting number, and that tells me how many significant figures my answer should have. 3.5 has 2 significant figures, so my answer should have 2. That is the 4 and the 9. So I've got to round the 9. I look at the next number over the 0, and it tells me to round the 9 down, which is how I get 49 grams of nitrogen down here. Okay, pause the video and see if you can do the next one. Welcome back. Let's do the you try together here. How many grams are in 2.85 moles of oxygen? So my starting number and unit is going to be 2.85 moles. and my ending unit is going to be grams. My conversion factor I'm going to have to get from the periodic table. It's going to be different for every element, and the periodic table shows us that oxygen has a molar mass of 15.999. So 1 mole of oxygen is equal to 15.99 grams. So that is going to be my conversion factor. I put my starting number in unit down here, 2.85 moles, and I'm going to multiply by my conversion factor. Again, I'm going to put moles on the bottom so that I can cancel it out. That is my objective. 1 mole is equal to 15.999 grams. That enables me to cancel moles out, leaves me with units of grams. And when I round everything correctly to 3 significant figures because of my starting number, I get 45.6 grams of oxygen. Okay, another example here. We're going to go in the other direction. We are going to be converting from grams to moles. So the question says, how many moles are in 40.3 grams of oxygen? So again, you've been given a number of grams, and you're trying to convert that into moles. So this is going in the other direction than our first 2 examples. I'm going to use the same conversion factor as the last one because we're still talking about oxygen. So 1 mole equals 15.999 grams. I'm going to put my starting number in the same place I always put it, 40.3. And I'm going to multiply by my conversion factor, but in this one, I am trying to get rid of grams, so I put grams on the bottom. So we flipped the conversion factor over compared to the last example that we did. That allows me to cancel out grams, and I take 40.3 and I divide it by 15.999. I round my answer to 3 significant figures because of my starting number, and I get 2.52 moles of oxygen. We should probably specify what element it is there. So we just figured out if you have 43 grams of oxygen, that is going to be equal to 2.52 moles. All right, pause the video and try the next one. Welcome back. Let's do the you try together. How many moles are in 112.45 grams of nitrogen? So read the question carefully. Try to get clear about what it's asking you to do. And in this case, we are converting from grams of oxygen into moles. So I take the number that I've been given, and that's my starting number in unit. And the thing I'm trying to figure out is my ending unit. So this is for nitrogen. So for nitrogen, I get off the periodic table that 1 mole is equal to 14.007 grams. That's going to be my conversion factor. My starting number in unit, as always, goes right here, 112.45 grams. And I'm going to multiply by my conversion factor. And I'm going to arrange it so that I can cancel the unit I am trying to get rid of out and convert to the other unit. So I'm going to put grams on the bottom and 1 mole on top. This enables me to cancel out grams because it appears on both top and bottom. Leaves me in units of moles for my answer. And the last thing I do is I divide 112.45 by 14.007, and I round to 5 significant figures because my starting number has 5 significant figures, and I get 8.0281 moles of nitrogen. Okay, as always, please let me know if you have any questions, email me, or just talk to me in class. Have a great day.